This is just a general strategy for solving systems of variables, but it's with elimination. There's another method, but we don't go over that in 1010, although we used to. Seems like we used to in 980, but either way, first thing, you got to choose a variable to eliminate. You got 3 variables to choose from, x, y's, and z's. Choose one to eliminate. Then you choose one equation to use twice. That may sound weird. We're going to use one of the equations twice, whether you want to or not. Okay. So because there's 3 equations, you're going to combine that one equation that you've chosen to combine it with the other 2 equations. And remember, you have a variable that you're eliminating. So when you make a system which is going to have 2 equations, you're just eliminating whatever variable you have chosen. But be methodical with that. So don't just be like, I'm going to eliminate the x's, because sometimes it can make things quite difficult. 3, use the one equation on the other 2 and eliminate the chosen variable. I guess I just kind of explained that. Again, we want to, I'm saying combine, it's just that we're using that elimination on the 2 sets of equations to eliminate the variable that we've chosen. But this will create 2 new equations, but then we'll only have 2 variables, which allows us to solve those 2 equations like we would a regular system of equations. I know some of this may not make sense, but hopefully it will when we go over the work. 4, use the 2 new equations to solve for the 2 remaining variables, just like I said, just like you would. And usually you're still using elimination with those 2, but you could use substitution. And then 5, use the 2 variables to solve for the final variable in one of the equations. And then once you get that variable, you can go back to the 2 new equations and solve for the variable that you don't have from the 2. And then once you have those 2 variables, you can use one of the original equations to solve for the final variable. But of course, the last thing you should do is check all 3 equations, because we're just using a calculator for it. Check all 3 equations just to make sure that you get true statements for all 3, because if you don't, it's going to suck. Because this is going to be a lot of work, just right? Like what I just said sounded like a lot of work, and I do make mistakes on this. So if some of you guys are like, what the crap is going on? Yeah, I make mistakes too, so just be prepared. All right, this one, here we go. So right here, let's say that we were choosing a variable to eliminate. Again, be methodical about this. Take your time and think about it. Looking at this system, I do not have to solve for z. How do I know I don't have to solve for z? Because it gave me the z right here. No need to solve for there. Is this going to happen all the time? No, we hit the jackpot. You're going to see one like this, of course, right? So what I can do now is I see the second equation here has a z and a y. It doesn't have an x. So right here in this equation, I can solve for y. So I'm going to set this up. Let's take this equation. Let's move this over here. Right, so it's showing y minus 2 times, that'd be 2 times z equals 14. But now we have a z value to replace into it. Now again, usually there's a lot of work that goes into solving for this z, but right now, no problems, right? So in solving for this one, I'll do it in green, I guess. So negative 2 times negative 4 is positive 8. So that would be y plus 8 equals 14.
For a minute, I thought that was a negative y.
Oh yeah, the arrow, my bad. But thank goodness it's not. So yeah, it's 0. Y now equals 6. Boom. You see how this, and this is, again, this is usually how this process would work after we have solved for one of the variables. So for the other problems, there's a lot of work in between getting to that point where they started us off, which is good. It's nice to start off in something that's fairly simple. Okay, now the first equation has the x's, y's, and the z's. So let's rewrite. I'm going to try that over. Let's rewrite that one. 4x minus 5y plus 2z equals negative 25, or at least it should be. So I know the y value. I made it green right there, so that's a 6. And then the z is negative 4. All right, let's solve this. So negative 5 times 6 is negative 30. 2 times negative 4 is negative 8. So now I've got 4x minus 30 minus 8 equals negative 25. Combine like terms. Negative 30 minus 8 would be negative 38. So now we got 4x minus 38 equals negative 25. And a couple principles of equality here. So add 38, but yeah, I gotta preserve some space there. Negative 25 plus 38 is positive 7, and I can drop my 4x. 4x.
I think it's 13. Yeah, it's 13.
It's not 7. It is 13. Thank you. So let's fix that. There we go. And I gave myself more space there, so that's also good. Divide both sides by 4, and I'm just going to show it as a fraction. X should be 13/4. Okay, now, again, is this actually going to work? Well, I just go to my calculator, and I do 4 times 13/4 minus 5 times the 6 plus 2 times negative 4. Enter, and that's negative 25. That one works. Let's try the next one. Y is a 6 minus 2 times negative 4. Enter, 14. And then the last one, we don't really even have to check that one, but we did find the X, so I'm gonna box that in.
Can you recommend